In this video, I'm going to talk about margin of error. So let's get rid of the conclusion. I mean, the conclusion is very important. By the way, before I erase it, this true proportion we're estimating is between these two numbers. They've added and subtracted a margin of error. So let's talk about that for a minute. Let's get rid of some of this writing and talk about the confidence interval that we just found. So first off, what's the distance of that interval? Distance or length of the interval. So you just subtract them. 0.4875 minus 0.3651 is 1224. Whoops. So that means 36 to 48 is roughly 12 percentage points. We want the in-between number, so chop that in half, and that's the margin of error. That's 0.612. And by the way, look at your calculator. I bet it said 0.612 when we worked that. Yeah, pretty close to it if we rounded. So back to the handout. You saw in the formula, we're adding and subtracting a margin of error. So think about it like this. 0.621 is the number of plausible standard deviations multiplied by the value of a standard deviation. That's how they got 0.612. Z times the standard deviation. If that helps you out, there you go. That's margin of error. Margin of error. Now, that's not the whole story. What is Z? Like, how did they decide on what the number of plausible standard deviations is? Well, they asked us to do 95% right there. So I need to find, this is the cool part about confidence intervals, I need to find the critical Z-score that represents the middle 95%. So you got to be careful if you do this by hand. If you do this by hand, you have to use the inverse normal function on your calculator, but it only does left area. It'll if you type in an upper bound, left area, I guess you could say, yeah, it has an upper bound, then it'll give you this Z-score. So don't forget, we have 0.025 area there, and we have 0.95 area here. So if I type in an area of 975, I'm going to get the critical Z value of 196. Let's look. I bet that's it. So menu, stats, distributions, inverse normal. It's been a while since we've done this. It's the left area. $1.95996, so 1.96. Here's another place where you can find it. The formula chart has already found many of these z-scores. You go to the second table, if you go to table B, so here's the Z curve, table A. See how it says Z on the top left? Here are the positive Z's. This next thing that we're getting ready to talk about is called the T distribution. But down here are Z values, that infinity row. And look right here. And look right here. They could ask you any of these confidence levels, and the corresponding Z-score, critical Z-value, is right above it. So if they asked for 99%, 2.576. If they ask for 90%, 1.645. Those three are the most popular, and 95% is the most popular. But they could ask for any of those, and there they are. All right? So that's margin of error. Margin of error is number of plausible standard deviations times the value of the standard deviation. And that's going to calculate margin of error. And if you struggle with that, you feel like they're just making things up, it's because they've decided if we do a 95% confidence interval, that means we have decided that 5% is not plausible, right? Okay. Moving on. Hope that made sense. If not, we'll talk about it more. Bye.